Welcome to Knowledge Base. Today we have a question that was also posted by one of our fans in one of the comment section of our videos. The question is on specific heat capacity. We have the question here. I'm not going to read the question because it's a bit long and we're just going to sort out the parameters while reading the question. So we're told that the mass of a piece of metal is 50 gram. So mass of metal equals to 50 gram. Converted to kilogram, you divide this by 1000, it will give us 0.05 kilogram. And we are told that it is heated to a temperature of 200 degrees Celsius. So the temperature of the metal is 200 degrees Celsius, and then dropped into a beaker containing 0.4 kilogram of water. Mass of water is 0.4 kilogram, which is initially at a temperature of 20 degrees Celsius. Temperature of water is 20 degrees Celsius. If the final equilibrium temperature of the mixture is 22.4 degrees Celsius, T, to represent the final temperature of the mixture, 22.4 degrees Celsius, calculate the specific heat capacity of the metal. Take the specific heat capacity of water as 4,200 joule per kg degrees Celsius. So the specific heat capacity, CW, of water is 4,200 joule per kilogram per degree Celsius. And we are told to calculate the specific heat capacity of the metal, which is Cm, specific heat capacity of the metal, question mark. So that's what we are looking for. These are the options to choose from, and we're just going to record the basic heat transfer formula, which says that the heat lost by the metal is equals to heat gained by water, because according to conservation law of energy, energy is not wasted. So if the hot metal at 200 degrees Celsius is dropped into a beaker of water, the heat that the metal will lose will be gained by the water. So the temperature of the metal will decrease and the temperature of the water will increase, and both of them will reach a unified temperature of 22.4 degrees Celsius. So what is the formula for heat? The formula for heat lost by the metal is giving us mass of the metal times specific heat capacity of the metal times the temperature change of the metal, and that is equal to the heat gained by water is mass of water times the specific capacity of water times the temperature change of water. So the temperature change of the metal is equals to the temperature of the metal at 200 minus the final temperature of the mixture at 22.4 degrees Celsius. So this formula is rewritten like this, while that of water is rewritten like this. The final temperature of the mixture minus the initial temperature of water. That is the change in temperature of water. So having this equation, we are just going to make Cm subject of the formula, because that is what we are looking for. We are calculating the specific capacity of the metal, which is Cm. If we make Cm subject of formula, then mm Cm minus T will all cross the equal to sign to the other side to become division, so that Cm will be equals to MWCWT minus TW divided by mm times Tm minus T, mm times Tm minus T, which is at the denominator. So we are just going to plug in the values from here into this, and we'll get our Cm, this is supposed to be Cm, yeah, specific capacity of metal, is equals to the mass of water, 0.4 times 4,200, specific capacity of water. The final temperature is 22.4 minus the temperature of water is 20, all over the mass of metal is 0.05 times the temperature of the metal is 200 minus the final temperature of the mixture, 22.4. So C, this is supposed to be Cm. So specific capacity of the metal is equals to 0.4 times 4,200 times 2.4. When you do the subtraction, all over 0.05 times 177.6 when you subtract 22.4 from 200. If you use your calculator for this, the specific capacity of the metal is equals to 454.1 joule per kilogram per degree Celsius. And that will give us option D as the correct answer. Thank you very much for watching, and see you in our next video. Bye for now.